We are going to go over this question. We consider the following two-step experiment. First, we get a random variable y, which is a sample with these probabilities. P of y equal 1 equal to P of y equal 2 equal to the probability of y equal 3, which is all 1 divided by 3. And now we have another detail. We know a Gaussian random variable x is sample according to x, which is distributed normally with y times mu and with sigma of 1. So the sigma is always 1, but the mu is changing based on the y we sampled. Now, given that y is unknown parameters, explain how we can utilize the EM algorithm to estimate it from n independent samples. So the first thing we can note, for people who are quick with statistics, we know that if we just do the expectations of all these values, we get twice on average, twice the mu. Why is that? Okay, we can show the calculation. So if we know E, I will open a new markdown. So if we do E on all the x's, okay, so we can do x1 to xn. What does it mean? It means we do E of y times mu, which is E, and because it's linear, we can do E of y times E of mu. And E of mu is just mu, so you can just keep it. And what is E of y? E of y is 1, the value of y, times 1 divided by 3, plus, so all of this in parentheses, okay, plus 2 times 1 divided by 3, plus 3 times 1 divided by 3. And all of this, I can tell you, is already, all these parentheses, E of y equal to 2, easy to calculate. So we get 2 mu. So we can not even answer the question, but just saying, okay, if you just do the expectations of all the x's, given that you have enough x's, it's on average going to converge into twice mu. So you can just divide it. Okay, so this is the first option. The second option is actually using the EM algorithm. How we use the EM algorithm? So I'm going to show you how I did it using Python. So we import some libraries, and then I choose the amount of x's we're going to generate as n. The mu, the actual mu is 10, but we can change it to be any value. The amount of iteration I want to do using the EM algorithm, and the sigma. The sigma is 1. They told us in the question which is 1, and easy peasy. So what I did was looping over all the n's. We get a random value for y, and then a random value based on that y for x, and just keep it all in a nice list of x's. Then I created a function for the probability density function for the Gaussian distribution, okay, with the mu, sigma, and x. This is pretty common. If you have any more question about that, I can show you. It's really easy. Okay, now we guessed M1, M2, and M3. Okay, this was just an initial guess. Know that this M1, M2, and M3 are not our actual mu. And then what I did was going over doing the EM iteration 600 times, so the amount of EM iterations. And for each one, we are going to calculate the sum of all the responsibilities and the values for the new M1, M2, and M3. So first, we calculated the probability density function for each one of the M. So given this M, what is the probability density function? Given the M2, what is the probability density function, etc. Now I calculated total probability density, okay, by just summing all of this. I know I can just, just add them together. It was easier for me to do a list if you want to, add more parameters. And then what we did, we calculated the responsibility of each one. So the responsibility of the first one, the second one, and the third one. And then we sum the responsibility. So the total responsibility we have. And now we calculated the M1 share of this responsibility. How do we do it? We just do the responsibility times the x1 value. Okay? So the amount from each point which relate to this responsibility. Then we do it for both M2 and M3. And then I just add it to the total sum, okay, the M1, the share of M2 and M3. And then to calculate the new M1, this is really easy. We just do M1 share sum, so the total amount of responsibility times each one of the x's divided by the total responsibility they have. Okay? And then I do the same for M2 and M3. And for each iteration, I appended the data. So we have a list of all the data. I printed the total value at the end. So we can see M1 is around 10, M2 is almost 20, and M3 is 30, which makes sense because the actual mu was 10. Now I just added all of this into a data frame. I show a sneak peek of the data frame and how the values actually change. So we can see M1 started at 4, then it jumped to 7.6, and 0.8, 9.3, and then just going toward 10 in a small incremental steps. You can see also M2 and M3, how they change over time. And now I did some Python code to plot the data. Okay, you can stop here and see what I did. And we can see here, this is the horizontal graph of the actual mu, which is 10. And we can see the blue line starting getting closer and closer to it. And the orange line is twice the mu, and the green line is 3 times the mu. Okay, just to note that this formula is the formula for the responsibility, and this is the formula to actually calculate the new responsibilities and the new values for each one of the m's. Okay, if you want, I just comment and I will send you also pictures of all the formulas and all their sources. And I hope you like these videos. I can also show you changing the parameters and see how it goes. So for example, let's change this to 7, and now we can do 2. Let's do 3, 6, and 9. Okay, because this is the first m, this is the second m, which have to be twice as much, and this is 3 times as the original. So now I will just rerun all the code, which will take around a second. Okay, we can see the new values is 7, 14, and 20. Now it's almost 21. And we can see the graph stays the same, and in around less than even 100 iteration, it converges to the actual values. So I hope you like this video. This is the EM algorithm for you. And until next time, I am out.